Hello everyone, this is Mr. Hu. Welcome to QuickCalc, and this is our first lesson, 1.1, a preview of calculus. So when we learn something, we're gonna know a general picture first, and the difference between my videos and others calculus videos online is we are focusing on cracking calculus AB and the BC course and the exam. So I'm gonna cut those useless informations and content, only focus the ones that will be repeatedly tested every single year. Alright, so first thing, what is the calculus AB BC course about? They're talking about two topics majorly. Of course, there's some small pieces. One is rates of change. Second is accumulation. Alright, so what is rates of change? Rates of change sounds something familiar? So we have another name, call it derivative. Derivative is a big terminology, only happen in calculus right now. But if I use another word, you're gonna find out very easily. It's slope. You learn slope in pre-algebra, 6th grade, 5th grade, all right? So for examples, I have a curve right here, and every single point on this curve has its own unique slope. And we can say this is the derivative at every single point on this curve. That's a general picture of derivative. All right, slope, just remember that. And the second, accumulation, this corresponding to integral. So what is integral here? I have an x-axis, I have a y-axis, and I draw a random curve. All right, I want to find out the area between the random curve forming with the x-axis. How can we find it? We don't know any formula. So what we can do is we cut this thing to be many rectangles, right? And we calculate every single rectangle's area, add them up, accumulates, right? And that equal to the area of this random curve. That's a general idea what is integral, all right? Okay, so there's a third topic we're gonna talk about today. Is secant line and the tangent line. So you might heard a little bit about it. This is calculus, so we're gonna redefine it, but actually they're just gonna reapply your knowledge from previous, like y equal to mx plus b. That sounds very familiar, right? This is slope-intercept form. So actually secant line, tangent line, eventually you're gonna both get to this form. Of course, you can use point and slope form, up to you. All right, just as long as it's a linear equation. All right, so how can we find a secant line? If the question gives you 2 points, any 2 points on the curve, you can find a secant line. First step, finding slope by using something familiar again. All right, y2 minus y1 divided by x2 minus x1. Just use this one to find the slope. Once you find the slope, you insert any points, P or Q, doesn't matter. Just insert 1 point and find out the value B. All right, then you find out the secant line. Any 2 points on the curve. So what is tangent line? A little bit different. So for tangent line, I use orange. You only have 1 point cut through this curve. You can only intersect once. It's right here, right? We call this line a tangent line. And actually the same deal. Eventually you're still gonna get this equation, and we still need to find out the slope and using 1 point. But slope here, we're gonna do something called taking derivative. So that part we can talk about later. But now you know the basic concept, what is secant line, what is tangent line. And if you like this video, you feel your math getting improved and you're learning well, please subscribe, and I'll see you tomorrow.